So hello everyone. We'll move on from this slide because you don't really need to look at us. It's myself, Rob Farndon, and Eric Prather will be delivering this jointly. So what we're doing here, first of all, is focusing around this overlap, if you like, between phase 2 and phase 3 and the interactions between the various elements at play here. So we're looking at, particularly, if I can have the next click, thank you. Yeah, we're looking at these particular elements associated with the flow, as Carl has described before. We've got the design record, the DFMEA, the process flow, and the process FMEA that follows on for it, and then process KCs and control planning. And these will form an onward path, a flight path through the entire APQP process that gets us to the point of understanding our control plan. Of course, there's a lot of team working involved in all of these elements. That's the first thing to say. So if I describe something as being a design activity or a ME activity or whatever else, it's actually a team sport. And all of these elements, they all talk to each other. I'm aware of a hand in the air. If there's a hand in the air, could you pop something in the chat so that we can deal with that separately? Thank you. Could I have the next slide, please? Thank you. Okay, so we're starting from the left-hand side of this picture and we're moving our way to the right. So the first thing to note is that we're starting through phase 2 and phase 3 of APQP here. And in phase 2, we have an emerging design. And we have an emerging design and we're going to represent that in the design record. So a drawing, let's say it's a drawing. And we have a number of characteristics identified on that drawing, some of which might be identified to be more important than others. They're all important, but some of them are even more important. So we start on the left-hand side. We have a process flow diagram, and we're dreaming up a process that will create those characteristics from our definition for us. And the characteristics we're choosing to number 10, 20, 30, sorry, the process steps we're choosing to number 10, 20, 30, 40. We'll be referring to that later. So we're saying what are the process steps and how do we sequence in them in the flow. The design FMEA up at the top, of course, design-led activity, but we want the MEs to be involved in this. We're trying to understand what are the known and unknown risks to the product, particularly focusing around the functionality of the product. And those aspects of the design that we're really worried about, those characteristics, we're going to mark as being product KCs. CIs are things we're worried about. KCs are things that we worry about that are subject to ongoing process control. And that's important from our point of view. So moving then on to the process FMEA, here we are taking our process flow diagram and the various process steps that are involved in creating the part, and we're asking ourselves, what are the risks associated with producing that specification, those characteristics? And again, some of them become more important than others, either because they respond particularly to creation of product cases, or because there's some underlying risk inside the production process. So we get a set of process key characteristics coming out of the PFMEA activity. If we can have the next click, please, that'd be great. So this is really saying these particular key characteristics, these particular process parameters could be controlled to actually achieve a better outcome within the production process such that we don't get defects. And particularly that is focused around the KCs. If we have the next click, please. We'll move on from there, from this understanding of our overall manufacturing process and the key steps within it, to inspection planning, test inspection planning, and the characteristics matrix. Now, in the characteristics matrix, we are taking those characteristics that are defined in the top left, and we are mapping it against the process flow diagram, process steps 10, 20, 30, 40 in this case, to form a matrix. And within the matrix is everything we need to be able to ensure goodness in the outcomes for our process in terms of achieving the specification. If we could have the next click, please. In the pre-launch control plan, we're identifying what data needs to be captured and what actions need to be taken during that phase in order to learn the process. And I'm sure we'll be talking around this much later on as well. Next click, please. So all of this is in the lead up to the production readiness review. And so we're going to be asking really, are all the deliverables that were created through phase 3, are they adequate to ensure the planning is there? Can we go into phase 4 in good shape so that we will have a successful outcome? Can I have another click, please? And we're going to use the new production readiness review form to confirm before we move on at the end of this phase. Okay, could I have the next slide? Thank you. So we're looking at now product mitigations, and these come through FMEAs of both types and DFX. If we could just have the build, please. Thank you. Yeah. So design FMEA is there to serve the purpose of improving the design such that it will achieve the product function. That's what it does. The process FMEA operates on the process flow, and it's there to ensure that the process will always achieve the product specification. So both DFMEA and PFMEA are all about defect reduction. They're trying to identify opportunities for improvement such that we don't get the defects. And DFX is to be viewed as a process that runs alongside both of those. We're trying to improve the design or the process by close collaboration between the design and manufacturing engineers. And the aim there, in whatever context, is to try and reduce the defect through the team working, through collaboration together. Okay, can I have the next slide, please? So, unpacking what DFX actually is, you can see it's designed for anything really, but it tends to focus around the downstream activities, design for assembly, design for manufacture, design for overhaul, etc. And there is always a set of things that we could consider doing to ensure a successful outcome, either for the design or in the manufacturing or overhaul process or whatever. We call those things controls. So the focus in the DFX sessions should be around which controls could be effectively deployed in order to make sure we don't get the defects. We've seen one example already. We saw a mistake proofing example on the Nissan car badge. But there's a whole realm of things that we could deploy. And these things are all to be considered in the context of design for manufacture, design for X conversation. Which of these are better to deploy is something that can only be determined when you think about the whole impact of introducing that control. It is a life cycle, if you like, decision. So actually they should be made in the context of an ongoing conversation between design and manufacture. And the reason for that is there are accommodations that design can make, and there are accommodations that manufacturer can make. And sometimes you need to move forward together to get an improvement. Thank you. Can I have the next slide? And I think this is where Eric takes over from me. Thank you, Eric.
Yeah, I'm Eric Prather from GE Aerospace. So what is this all about, right? We're talking process controls. So how do we improve our process to really reduce defects and escapes? We've mentioned a lot of documents, but one of the big things we want to get out of this is the interconnectivity of the documents, right? They're not one-offs. We're looking at a system approach is APQP. How are we doing all of these things together and not just as one-offs? Hey, we checked the box, now we can submit a PPAP, but how are we actually getting benefit and making this how we manage quality? So here we see, back to the previous, in yellow, we have our characteristics showing what are the product characteristics, right? What's on the drawing, what are in our specs, and those are going to be consistently shown in yellow. And we show how those relate to our operations. So those big steps in the red circles. So across these documents, we kind of see how they move in and out of each other and how they relate. So what we want to do is we want to use the APQP elements to align process and product requirements so that our control strategy can really be robust. Next slide, please. So what are we getting out of the PFMEA? PFMEA is a big one. It's very popular, comes up a lot. PFMEA is to identify risk. So we want to reduce that risk, and we do that by changing controls. So we look at severity, occurrence, and detection. Severity, how large is the impact if we fail to meet our requirements? And impact is the word that I really like people to take away when we talk severity, right? We want to know how bad is it? So to improve our severity, we can design out the impact that we have in our defects. Typically, we're only going to improve severity through design change or a better understanding of what is our process, right? It's hard to put in controls around severity that don't really change the part fundamentally. Into occurrence, how likely is our process to create a part that does not meet requirements? We improve this by preventing defects, right? It doesn't matter if we're going to catch it or not. We don't want to make it in the first place. And this is where we really should focus our control effort is catching defects is too late because then we have a chance they might get out. So let's stop them completely. This is going to improve with the prevention controls that we have in our PFMEA. And again, it's that reduction of frequency of creation of the defects. And then for detection, how likely are we to find a defect when it's made? So this one's easy. It goes along with our detection controls in the PFMEA. And this is the chance that it gets past you. So if it's made, how likely are we to catch it? And all of these really need to be viewed independently of each other, right? We want to look at them independently so that we can put in the right controls. So down on the bottom left, we have some prevention control methods. So that's really to help our occurrence, right? These are a couple things that we might use. And then we have detection mitigations over on the right. So some control strategies that might be put in place to help reduce that risk around detection. So again, for this slide, PFMEA is to highlight the risk in the process. And it's the implementation of our improved controls where we actually create the benefit, right? Doing a PFMEA just tells us where we have problems. It's those continued actions after the PFMEA to improve our control strategy where we actually see real and tangible benefits in our process. Next slide, please. So here's the characteristic matrix. It's a great tool. It is an optional tool, but we really preach it for how beneficial it can be. The way the characteristic matrix works is we look at our process and where are we affecting the part itself. So how can we have in-process changes and when do we get the final touch on the part where that dimension, for example, might not change anymore before we ship it out. There are different times that we can control our process. So here, finding it at the top, finding it is good, right? We absolutely have to find every defect that we make, but this is downstream inspection, right? So maybe we've put in some value add along the way. There's a chance it gets out. It's not going to be 100% inspective or 100% inspect. Inspection is not 100% effective. I'm struggling today. So looking at this little diagram we have, the process operations are shown where green is good parts, red is bad parts. We're moving them down the line towards inspection, but we have a lot of WIP. So it's going to be hard to really intervene when we find a problem. The step below that, control, is a much better strategy. So in process inspection, we're not sending things downstream. We don't have a bunch of WIP built up. We're not putting value into the part that we might have to rework or scrap. We want to move our inspection as close to the point of generation as possible. Finally, stopping them all together is best. Prevention at the source. You know, can we error-proof it? Can we poka-yoke it? Do we have mistake-proof devices, preset checks? What controls do we have in place that are stopping defects before they can get past us? Because if we're not making bad parts, we can't ship bad parts. So the characteristic matrix is going to show us every point in which the part is modified. And that's where we have opportunity to intervene and put controls in place and to put error proofing in place to make sure that we aren't shipping anything effective. If you go to the next slide, please. So we keep talking about controls, and one thing that comes up a lot, it's the process control strategy. How do we choose what controls to use? So there's no right or wrong answer. Considerations for choosing the controls, these are some of the big questions that we ask below, right? So first things first, this is your process. There isn't a right or wrong. You have to choose something that is going to work for you and your site. No one can just give you the answer and dictate your process. What is the criticality or RPN as defined in the PFMEA? So we're trying to put a risk evaluation to each process and characteristic in the PFMEA. If we have a high risk item, do we need stricter controls in place? Because that's how we bring those scores down. The volume of parts being produced. Do we have enough parts for really strong statistical sampling? Would enough parts be produced to justify maybe a bookending strategy? These are huge considerations, especially in our business that has a lot of kind of low volume production. Right? Some of these are a lot easier when you're making 1,000 parts a week. So that's a balance that we have to strike. Another question is, what is the difficulty of the quality check? Is it a destructive test? We can't put 100% controls in place if we have to cut the part open every time. How long does the inspection take? CMMs are very popular and getting more popular. And we have a lot of very complex components in our industry. And so how are we making sure that we don't bottleneck ourselves in production by saying, well, everything has to go through the CMM, and that really, causing us over control in this place. So whatever we choose, right, we have to ensure that everything is documented and correctly implemented in production, right? So many times these documents end up just living on paper. We need to live this, and we need to actually implement and do all of this hard work and these ideas that our teams put together. If we can go to the next slide. So zero defect spotlight on the APQP elements here, right? That's everything here, the highlighted numbers. And then everything in blue is the PPAP evidence. So these are things that get submitted as part of the PPAP. So after the webinar, you can find the RMs that talk about all of this. So great reference, like Carl mentioned earlier, but RM 13145, 13004, 13006 are really the focus today. But these are really important guidance that we strongly recommend everyone to look at and use regularly.